All right, Mr. Ahmed here for 8.1. We are going to start up chapter 8, which involves similarity. And we are first going to talk about similar polygons. So our central question is, how do I use similar polygons in a mathematical application? And the first process that we're going to go over before we actually hop into the similar polygons is just a brief little algebra reminder of how to cross multiply. So when I have two fractions equal to each other, oftentimes it's easiest to solve this by cross multiplying. To cross multiply, I just make an x. I take x times 8, which is 8x, keep my equal sign in the middle, and then do 4 times 3, which is 12. In order for us to solve, we'll divide both sides by 8, and x would equal, yes, indeed, I have a fraction. I have 3 over 2. We can get fractions for answers. That's also considered to be 1.5. Next one. X times 3 is 3x, and 12 times 5 is, I believe, 60. Gonna do a double check. It is indeed 60. Divide both sides by 3 to isolate, and we get 20. All right, next one, we have a quadratic forming. Keep in mind, x times x is x squared. 9 times 1 is 9. Now, for us to solve this, we can take the square root of both sides. Now, technically for this one, when I insert a square root, it needs to be both a positive and a negative value. And the solution is x is equal to plus or minus 3. The reason why it's both positive 3 and negative 3 is because 3 squared is 9, and negative 3 squared is also 9. All right, on to the next one. This one I'm going to have to distribute. All right, I can take 2 times 3 first, that's 6. Now this one I have to do 5 times x plus 3. I have to multiply the whole thing. Distribute 5x plus 15 equals 6. Subtract our 15 from both sides. And 6 minus 15 is negative 9 equals 5x. And again, I get another fraction. We can get them. X is equal to negative 9 over 5. Okay. Our next one is pretty much the same exact thing. I'm going to have to distribute. 12 times 3 is 36. I'm going to draw a little line here. 36 equals negative 7 times 4 minus x. All right, when I distribute, negative 28, negative times a negative is a plus 7x equals 36. Add our 28 to both sides. 36 plus 28 is 64. Equals 7x, divide by 7, divide by 7, and again I get another fraction. X is equal to 64 over 7. We will leave it right there as a fraction. Now this last one, super challenging one. Like we practiced factoring, this is the reason why. We are going to start seeing some quadratics appear. All right, so 1 times 9 is 9 equals. Now I have to take x minus 3 times 2x plus 1. For us to do that, I have to FOIL. Distribute the x. X times 2x is 2x squared. X times 1 is plus 1x. Now I distribute my negative 3. I get negative 6x and negative 3 equals 9. Now in order to solve a quadratic, we have to set it equal to 0. So I'm going to subtract 9 from both sides. Those cancel. 0 equals 2x squared. 1 minus 6 is minus 5x. Negative 3 minus 9 is negative 12. Now, from this stage, you could plug this into the quadratic equation to solve it, or you could factor it. I'm going to factor it. I'm going to use the AC method. 2 times negative 12 is negative 24. And we have to find the factors of negative 24 that add up to negative 5. That's negative 8 and positive 3. So I'll rewrite it. 2x squared minus 8x plus 3x minus 12 equals 0. So we replace that middle term with a negative 8 and a positive 3. Then we factor by grouping. Take out the 2x. Still equal to 0. So 2x comes out of these two terms. We're left with an x minus 4. Here I can take out a 3, so plus 3, left with x minus 4. So we got it factored now. Take the 2 that were outside, which is the 2x plus 3, and the x minus 4. Then we have to solve. First solution, 4 minus 4 is 0, so x is equal to 4. Second solution is when 2x plus 3 is equal to 0. That's 2x equals negative 3. X is equal to negative 3 over 2. So that is an example of a more challenging quadratic, but like we said, they will start appearing. All right, after our review of cross multiplying, we are now going to work into our similar polygons. So in the diagram below, we have two similar triangles. Triangle ABC is similar to triangle DEF, okay? We can write that ABC is similar to DEF using a little squiggly sign in between. This is the mark for similar, all right? A similarity transformation preserves angle measures. So the angles are congruent, okay? When we have two similar figures, their corresponding angles are always going to be congruent. And it's either going to enlarge or reduce the side lengths by a scale factor. All right, so when we write the scale factor, we're going to talk about that on the next page. So in this diagram, a couple of key things here. Angle A in the statement corresponds with D, so angle A is congruent to angle D. All right, in the statement, angle B and E are congruent. Yep, we got that, and A and D. So those are the congruent angles. And then, since the side lengths are proportional by a scale factor, I can write it as DE corresponds with BA. So DE over AB is equal to EF over BC, and then FD over AC. So the corresponding parts are how we're going to set up the proportions. Quick little reminder on the scale factor. The scale factor K, this was when we were doing our transformations, is the ratio of any two corresponding side lengths in similar figures. All right, the image is the final appearance of a figure, so that's what we end with. The pre-image is what we start with. When I set up the scale factor, it needs to be image over pre-image, which is new over old, okay? So hopefully we recalled that from a couple chapters ago. So, clarification of one thing. Oftentimes, we'll see it as find the scale factor from A to B. This is a little bit confusing, all right? This isn't saying write the ratio of A to B. It is stating that the figure went from A to B, all right? So that means that B is the new one and A is the old one, all right? So when I see this, the figure I start with is A, so this is the pre-image, so this is the old, and this is the new. Okay, so when I write the scale factor, it has to be new over old, so B over A. All right, so first example says, find the scale factor of triangle RST to XYZ. So a couple key things here that we have to notice which parts are corresponding. All right, so RS corresponds with XY. So I'm just going to highlight that. RS corresponds with XY. Those were the first two letters. In a similar manner, ST corresponds with ZY. ST, ZY, those were the last two letters, okay? And then the side that's not highlighted corresponds as well. So to find the scale factor of RST to XYZ, that means I went from RST to XYZ. So this is the old, this is the new. So the scale factor has to be the corresponding side length. Let's just take 18 and 30. It has to be 18 over 30. And we can reduce that down because 6 goes into 18. That's 3 over 5. That is K. We found the scale factor. Now to list the corresponding angles that are congruent. R corresponds with X, so angle R is congruent to angle X. Angle S is congruent to angle Y, and angle T is congruent to angle Z. All right, so that's how we find the corresponding angles. Now it says write the ratios of the corresponding side lengths in a statement of proportionality. So I need to set up the corresponding side lengths using the correct scale factor. So it was new over old, so ZY over TS, took the yellows, is equal to XY over RS, took the oranges. And then lastly, ZX over TR. All right, so that is our process there. Just make sure you identify the new and the old figure. Next example says, in the diagram, triangle JKL is similar to PQR. Find the scale factor from JKL to PQR. So that means this is the old, this is the new, okay? Now, for us to find the scale factor, pair the corresponding sides. It appears that KL corresponds with QR, so they are drawn similarly. New over old would be 6 over 4. So scale factor is equal to 6 over 4, which is 3 over 2. Found the scale factor. Now we're supposed to list the corresponding angles that are congruent. So angle K is congruent to Q. Notice from the statement, K and Q are both in the middle. Starting with that, angle K is congruent to angle Q. My next one, angle J, is congruent to angle P. And lastly, angle L is congruent to angle R. Okay, so we just need to use the statement for that. Now, for the statement of proportionality for the side lengths, order is not important really. I can do whichever one over, or whichever corresponding parts first. I'm going to start with QR over KL is equal to PR over JL, and that's also equal to QP over KJ. All right, and that would be our process for those. Corresponding lengths and similar polygons. All right, so if two polygons are similar, then the ratio of any two corresponding side lengths is equal to the scale factor. So we can set up proportions to find missing sides. All right, so when I'm setting up this proportion to find the missing sides, the order is not necessarily important of if I go new over old. I can kind of set it up however I want. I just need to keep it in line. So I'm going to go with the little one over the bigger one. So X corresponds with 30. X over 30. EF corresponds with NP. So X over 30 is equal to, I could say 15 over 18, or I could use 20 over 24. I'm going to go 15 over 18. And I will cross multiply to solve this. So X times 18 is 18X. And 30 times 15, I'm going to use a calculator for that. 30 times 15 is 450. Divide by 18, and we get 25. Now, I want to show you one thing. I chose to set it up this way. Now, notice how the way it was set up. It went from here to here. So this would technically probably be considered the new, this the old. So I could have set it up the other way around. All right, I have some options here. I could have done 30 over X is equal to. So I chose 30 over X. Let's try it this way. 18 over 15. That's the same way I did it. I just flipped it around. So let's see if we get the same answer. 18X equals 30 times 15. Same exact thing, 450. And I still get X to equal 25. So we do have some options on how we set those up. Example 3, another finding the missing part. This time we are going to look for the length of PS. PS is called an altitude. It goes from the one side of the triangle to one vertex of a triangle to another side at a right angle. So we're looking for PS, that is X. So when I set this up, I'm going to say 20 corresponds with X, so 20 over X is equal to this entire side length, 16 over 12. Then we'll cross multiply to solve. 16X is equal to 20 times 12. That's 240. Divide by 16. We get X to equal 15. So PS is equal to 15, because that was the piece we were finding, PS. All right, next one, find the value of X. Make sure we set up the corresponding parts. So BC corresponds with RS, which is kind of drawn that way. So we'll go X over 4 is equal to another set of corresponding parts. Let's go 16 over 8. All right, now we will cross multiply to solve. 8X equals 4 times 16. That's 64. divide, and x is equal to 8. So we found that missing piece, and we kind of notice it's double. This is 8. 4 times 2. 8 times 2. 5 times 2. 6 times 2. They all have the same ratio. All right, just a couple left here, and then we're wrapping up 8.1. So the first part says, find the scale factor, then list all the pairs of congruent angles, and write the ratios of the corresponding sides. So it's going from here to here. Notice the arrow. So this is our new, this is our old. So when I set up the scale factor, I'm abbreviating that SF. Scale factor equals new over old, 30 over 10. I took the 30 corresponding with the 10. 30 over 10 reduces to 3. Okay, so it was an enlargement. It grew by 3 times the amount. The congruent angles. Angle L is congruent to Q. LQ. M is congruent to R. And N is congruent to S. And then lastly, setting up the ratio of the sides. LM. Whoops, I went backwards. Oops. LM was over here. I have to start with the new, so that's QR over LM is equal to QS over LN, and that's equal to, which piece haven't I done? SR over MNM. And there is my statement of proportionality. I have scale factor, congruent angle, statement of proportionality. And finally, one last step, find the value of x. So we got to figure out what side x corresponds with. Angle's congruent, x corresponds with 6, so x over 6 equals, let's go right angle to here, 4 over 8. Corresponding parts, x corresponds with 6, and 4 corresponds with 8. And we'll cross multiply to solve. 8x equals 24, x is equal to 3. That's it for 8.1 part 1. Have a good one.